And welcome back. We are going to continue work with variables. Today we're going to do a little bit of variable arithmetic in order to do some more complex things. Not too hard, but we will be able to do a lot more than simply just displaying variables out through our print line statements. So the very first thing we're going to talk about with arithmetic operations is that, as you might have already guessed, that these are things that you can do in math. So whether that's adding, subtracting, multiplying, dividing, or even something you may not be as familiar with, but you might have some recollection of, is the modulo operator, or what is also for us known as finding the remainder. And for that one, it's a little different symbol than you might be used to, which is this percent sign. But that's the one that we're going to end up using. And this will come in handy as we get a little further in the course. Maybe not as much right now. You may not see as much value to it because these ones are pretty straightforward. But again, this one will be an operation that you will use. Now, a couple notes is that if both of your numbers, when you're doing an operation, are of type int, then your answer is going to be of type int. However, if one or both of your numbers are of type double, then your answer will be a double. So to demonstrate this, I'm hopped over to Eclipse here. I went ahead and pre-populated some code here. And the very first thing I want to show, if we look here, we have num1 plus num2. Num1 is, of course, a integer type, and I've set that to the value of 1. Number 1 is a double, which is, of course, the value 1.0. Now, I can technically go ahead and leave this as 1. I'll show you that here in a sec, but we know this is a double, which means it has a decimal. So if I go ahead and run this, we get the value of 2.0. Now, if I change this over to just a regular 1, you'll see we still get the value of 2.0, and that's because Java says, oh, this is a double, which means you actually mean that this is a decimal. And anytime we add a integer plus a double in this case, or a decimal, we're going to get a decimal answer. Now, if I were to go ahead and just add one line of code real quick here, and just do 2 integers added, you'll see that we should, of course, get an integer output, which is kind of what we would expect. So I'll just do num1 plus num2, save that, go ahead and run our program, and you'll see we get a integer output. But again, when we do int plus double, we get a decimal. All right, now one other note, of course, if we are doing both double, like I said, those are both double. I know I didn't show that, but just keep that in mind as we move forward. Now, there are precedence rules that we do need to adhere to, and precedence is a fancy way of us saying, hey, this needs to come before this. And in math, we're very familiar with this. This is called the orders of operations. And just like in math, Java has a set of rules that it's going to follow from the left to the right. Now, our highest precedence is things like plus plus, minus minus, or otherwise known as the incrementer and decrementer. We haven't talked about those, so just kind of put that in kind of a pocket for now, and just we'll worry about that later. We have the exclamation mark, which means not. Again, this is something we haven't talked about yet at this point, so again, you can kind of just follow that away. And then parentheses. Anything inside of parentheses, as you might know from orders of operation, will happen first. Our medium precedence, we have, of course, multiplication, division, and the modules operator actually shares the same level of precedence as multiplication and division. And that's because if you think about it, when we do the remainder, what are we doing? We're having to do some division. Now, the lowest precedence, of course, is going to be our addition and our subtraction. Just like how we have our normal orders of operation, addition and subtraction kind of sit near the bottom of the rung. Now, we do need to, of course, talk about integer and floating point division, which, of course, we've seen a little bit with the int and the double example. But I want to give us a little bit more concrete one, just to kind of give you a heads up. So, for example, in math, if we do something like 10 divided by 3, we're going to get an answer of 3 1/3, or 3.3333 repeating. Now, if you try doing that with an int in programming, all right, we're not going to get 3 1/3. All right, if we do that with double, we'll get 3.3 repeating. But with integers, we won't. Instead, we're going to get the value of 3 and not 3 1/3. Our answer is not going to be rounded. Instead, it's going to pretty much ignore everything after the decimal point. So if I were to do that here in my example, I'm just going to go ahead and change some stuff here. Let's change num1 to 10. Num2 will change to 3. And let's just go ahead and change this from an addition operation to a division operation. So we should have 10 divided by 3. And so if I go ahead and run my code, you see I get the value of 3, which of course is not what we're used to seeing. So if we want to get our traditional 3.3 repeating, we actually need to either use a double or a float if we're trying to get a decimal answer. So for example, I did 10.0 divided by 3, we would get the correct number of 3 1/3. And so we could do, like, say, if we took our double number 1 and set that to 10, and then we divided that by the integer num2, which was set to 3, we would get this correct value. Now, the modulus operator is something that we're a little maybe unfamiliar with, even though the concept of a remainder might be familiar to us. And what the modulus operator does, it finds the remainder. So if I did 10 modulus 3, we would get the remainder. Of course, if I did that, I would get the answer 1. I'm not going to get like 3 remainder 1. It's simply just going to give me 1, because 3 would be the quotient. That would be what we would find from doing a division operation. And we know that this is going to be 1 because, again, 3 goes into 10 3 times with a remainder of 1. So that's very important to keep in track here. When we talk about modulus, we're simply looking at the remainder. We're not interested in the quotient. If we want the quotient, we'll just do regular integer division. Now, we can use modulus to calculate the remainder for any other number. So we use 3 here, but this applies to any other number, whether it's 2, 4, 5, whatever. And very often, the modulus is used in programming. We want to find, for example, every certain number. So let's just say if we have a list of numbers and we want to print like every third number, well, we could use the modulus operator to find out in that list which number is third. So, okay, we're going to print the third number and the sixth number and the ninth number. And rather than having to try and go through and manually count it, we can just use the modulus operator to help us with that. Now, of course, we've already seen this, but we need to talk about operations on variables. We can use arithmetic operations on variables very, very easily. We would simply just use the variables as we would pretty much any other number. As we saw, I did like num1 plus num2. That is a arithmetic operation on 2 variables. But one thing I want to caution here is if we want to, let's say, create a new variable, let's say num3, and we want to have that value of num1 plus 2, we have to store this back. Otherwise, if I say num1 plus num2, it's not going to do us any good. So the other thing we could do is we could output that number. So here's 2 examples. So I have int new number equals number 1 plus number 2, or system.out.println number 1 plus number 2. This, of course, will give me the answer, but it's not going to keep this. Once this print line happens, the program no longer knows what this sum is. So if I want to record this, because let's say I want to take this sum and use it in another operation, well, then I need to store it into a new variable, or if I want to update one of these variables, I can do that as well. And that gets us really into this next slide, which is talking about combination operators. Now, combination operators is a little bit more advanced, and if you aren't comfortable with doing them, it's not a requirement, but it is something that could make your life a little easier, or you may encounter people using combination operators. So we can combine simple operations, such as addition and an equals, or minus and equals, times equals, division equals. And what this does is it puts these operators so that way they function away. So if we want to take the value and store it back into one of our variables, it allows us to do this. So for example, if I have int num1 is equal to 1 and int num2 is 2, and I say, well, I want num1 to equal the value of num1 plus num2, I could write out num1 equals num1 plus num2, or I can do num1 plus equals num2. And what that will do is it'll add these 2 numbers, but then it says, hey, this number comes first, so it's going to take whatever the sum of these 2 numbers is and store it back into that first number. So let's go ahead and look at a little bit of that with Eclipse. So I have here a num3, and so let's just go ahead and say num3. All right, if I just have num3 by itself, it's going to just exist. But let's just do for a second do num1 plus num2. And just to show you, if I just put num1 plus num2 here, you notice that the compiler is not happy with me. Or Eclipse is saying, hey, you've added these numbers, but I don't know what you want to do with them. It is fine if we put this by itself inside of a println statement. So if I just do system.out.println and I do num1 plus num2, one of the things you'll notice is that there's no errors here. But here there is, because again, it doesn't know what you want to do with this. And so we have to store this back into something. So this might be num3 equals num1 plus num2. And now, because these two numbers are stored here, you notice that the error goes away and the program is happy. Now, if I wanted instead, let's say, to have this be a sum of something else. So let's just say we want to, from here, do that plus equals. I could say num1 equals num1 plus num2. Or we can also do this by doing num1 plus equals num2. Now, again, both of these are the same. And if I were to output them, you would see that they are the same. Now, so let's just go ahead and do some print line statements here. So just so we can see these real quick. So I'm just going to do system.out.println of num3. And then make my life easier. I'm just going to copy that and let's paste this in here. And we'll just go ahead and change these each to num1. Now, one thing I am going to want to do here, because I want to test this here, is I actually need to go and change num1 back to its original value, which of course in this case, this is 10. So after I go ahead and do this, I want to make sure I set num1 back to the value of 10. So this is of course going to go ahead and change this for me. I actually bumped a key here. There we go. And so now if we go ahead and run this, we should have num3 be equal to the sum of num1 plus num2. Print it out. And num1 is then equal to num1 plus num2. And we're going to print out, we're going to reset num1 back to 10, which is what we have up here. Then we're going to output that sum. So these two numbers we should expect to be the same. So let's go ahead and run our code. And sure enough, we can see we have 13, which is of course num1 plus num2, which we're storing into a separate variable. We have num1 being updated with the value of num1 plus num2. And then, of course, this is the same thing. It's the update of num1 plus num2. All right, and that's going to give us a nice, good foundation here to be able to start doing some arithmetic operations as we get deeper and deeper into our programming.